So we're going to talk about the modes of buckling. All right. So for this, so for this example, I'm going to show we're only going to be talking about a pin column. All right. So if you look at the figure at the bottom of the screen here, all right, that's what we're talking about. So there's a force being applied at the top of the beam. It's constricted with a pin on the bottom and a pin on the top. All right. So for that, the loads, critical loads of buckling, we can describe them in terms of the modes. So there's mode 1, mode 2, and mode 3 with the letter N. All right, so the critical loads would be described with this equation on the left-hand side, and then the shapes of those different columns, or for each mode, would be described with the equation on the right. So for the first mode of buckling, or when N is equal to 1, we can say that the critical load is equal to pi squared times e to the I z over L squared. Right? Well, for the shape of that first mode, we can say it's equal to pi sine of pi x over L. Right? So in some cases, you can reinforce columns by adding additional supports, such as like if you add a support in the middle of the column. So in that case, the first mode of the buckling is compressed, so the next mode of interest would be when n is equal to 2. All right, so that's our second mode of buckling, which is described visually in this equation here. Right. So in that case, our critical load that would cause buckling in this column would be equal to 4 times pi squared over the length squared times e to the I z, all right? And then BC of 2 would be equal to delta sine of 2 pi x over L.